Miniature Steam Hacks, Hints and Tips. This one's called Essential Basic Knowledge. It's a compilation video with lots of useful information. The model steam engines that I currently build and work on are much simpler than this Black 5. This is an engine I've been working on recently. It's a Stuart Turner 5A, and I've just added the reversing gear to it. As you can see, there are many moving parts. Not quite as many as on a locomotive, but still a lot of moving parts. When you make these parts and when you fit these parts, you need to treat every individual part as a model in its own right. If any part of the engine is not right, for instance the crankshaft, if the crankshaft isn't true and is difficult to turn, the rest of the engine will never be right, and you will compound the problems and end up with an engine that sounds like a pneumatic drill when it's running. This engine is a very old Stuart S50, and it's got some play in the main bearings and some play in the big ends. But by carefully adjusting the valve timing for early admission, as mentioned in another video of this series, it cushions the blow to the piston and the engine doesn't rattle so much. It really needs the bearings bushing, the problem being that with an S50, even though it looks like it's got proper plumber blocks and proper bearings, these are simply solid cast iron. But the original builder of this engine machined off the cast iron bolts and fitted proper bolts. I think if I'd have been doing it, I would have split the bearing at the same time. But anyway, to fix this, it just needs phosphor bronze bushes fitting and maybe a crank pin too. I'm not going to really bother with this. It's such a small engine and it runs okay for what it is. Most of these end up on a shelf anyway as a display item. The point of showing this is to illustrate how important it is to have a crankshaft, a crank web and a flywheel sat in bearings that are perfectly parallel and a good fit to the crankshaft. Some Stuart engines, such as the Victoria, the James Coombs and the Beam engine, use a system whereby one end of the crankshaft is supported on the main bed casting and the other end is supported on a pedestal. And before you go any further, it's essential to make sure that the pedestal and the bed casting are in perfect alignment. Rather than build the engine loose on the bench, it's a good idea to bolt the thing down. And before you make any other parts for the engine, make sure that this crankshaft spins and feels really good when you turn it. If the crankshaft is out of alignment, things like this, the eccentrics and the water pump drive, not to mention the connecting rod big end, will all be out of alignment and the engine will not run properly. Like all steam engines, it will turn over, but it won't sound too good. And it will, of course, wear in after a while and stop clunking quite as badly. But this is not really what engineering is about. So whether you're building an engine from scratch or repairing one, build it in modular form. Start from the bottom up. Remember, if the crankshaft isn't right, no other part of the engine will be right either. If you've been watching my other videos of these engines and others running, you'll see that they run fairly quietly. Not all of them are new, some of them are quite old. But I always take my time to get the separate components to run in harmony with each other. I'm not an engineer, by the way, I'm a musician. And I've had no formal training in lathe operating, milling machine operating, or anything to do with mechanical engineering. But what I do have is a great deal of common sense. Another good thing to do, that isn't shown on many of the drawings, is always drill a hole in the bottom of the eccentric. This allows an Allen key to go into the eccentric sheave, and it's much easier to adjust the eccentric, assuming of course that you're using eccentric sheaves that have a grub screw somewhere in the sheave holding it to the crankshaft. The other option is that you have to take the eccentrics off to make adjustments, and after a while you'll slip into a coma doing this. Even simple Stephenson's link valve gear always surprises me how well it works, and the fact that you can bang it into reverse straight away whilst the engine's still under power. It really is essential to make sure that nothing binds on the expansion link. The expansion link is the oval shaped thing in the middle. If the valve fork binds on the expansion link, when you move the lever across, you're likely to smash the expansion link. I've done this a few times in the past, so I know what I'm speaking about. Valve gear has to be made accurately, including the operating lever. This must remain at a fixed 90 degrees. It must not flop about on the shaft. If it does move, then it will wear the expansion link unduly, and also the valve events will not be correct, so you'll never get a good forward and reverse setting. Always cross drill them and fit a taper pin. I cannot stress how important the quality of lubrication and the type of lubrication is. If you use the wrong type of oil, you will do more damage. and do not use oil additives at this stage. Oil additives are very useful for lowering friction, but you don't want to do that. If you use oil additives, the engine will not run in properly. I normally use simple machine oil. A good quality machine oil such as lathe spindle oil is ideal. Don't use motor oil. Motor oil needs to be warm to function, and it's too thick to get to where you need it on the bearings. Even though the metal looks smooth, it isn't at all. Later on I'll show you a magnified view. Just to digress for a moment, this is a quick tip. When using slotted grub screws, always make sure that the slot is below the surface level, because otherwise if you put pressure on the slot with a screwdriver, one half of the slot normally breaks off, and then you end up with a broken grub screw, and it may be difficult to get it out. So make sure that the grub screw is definitely below surface level, which supports the sides of the slot. This is a Stuart Turner James Coombs engine, and it's a very weird engine really, with the crosshead above the cylinder and a very complicated linkage from the eccentric to the valve chest. And one problem that I've had with this engine is that the eccentric is still a little tight, and this is causing the valve links to kick a little bit and make a slight noise. But after a while this will disappear. As I mentioned earlier on, the purpose of running in is to smooth out the surface of the metal, and if you look at this magnified section of a piece of metal, you'll see that it's awfully rough under a microscope. It looks like a lot of hills and valleys, and the real purpose of running in is to remove the hills. You still need the valleys in the metal. That will hold the lubricating oil. A good indicator of the status of the running in procedure is the colour of the lubricating oil that is exuding from most of the parts of the model. Here you see down this green part, nasty black oil. This is oil mixed with the metal residue from the bearing. And this is nothing to worry about on a new engine or an engine that's had some new parts fitted. But if this continues into the life of the engine, then something is wrong and needs investigating. If the oil's coming from the main bearings, it could be either that the caps are too tight, putting too much pressure on the bearing, or the bearings got scored and is re-wearing itself back into play. Here you can see some black oil around the gland nut of this beam engine. This is because the gland's been recently fitted and it's quite tight. After a while the black oil disappeared. Looking at the exhaust pipe, you will see black oil coming out of there too. This should happen for a while, particularly as the piston does a lot of work and wears itself into the bore. If your steam engine has a piston that's packed with graphited yarn, also known as soft packings, you will get some black residue like this until it all settles down. With this James Coombs model engine, after a couple of hours running, the exhaust residue became very clear. The oil that came out was the same colour as the oil that went in. But steam engines like this are better run at a scale type speed, more like you see here, nice and steady. Although sometimes it is good fun to open the regulator wide and watch the engine spin away. This has a governor, but the linkage is quite ineffective. It does not shut off the steam properly, or in this case compressed air. An engine of this type going like this, it nearly dances off the bench. Usually when I've finished rebuilding an engine, I run it at warp speed for a few seconds like this, and I don't recommend this, but it does show you that the engine's in good order. If anything was wrong, it would really show up at this speed. But don't do this for a prolonged period, because the oil will be spun off by centrifugal force and you'll end up with dry bearings very quickly. A quick word about oil additives. A few years ago I was working at an oil refinery in Glasgow, and I was speaking to a laboratory man, and I was asking him which is the best oil additive, and he said, by far, without a doubt, rapeseed oil is the best additive. And I thought, what? Rapeseed oil? But then he went into great detail about it, talking about such things as long chain molecules and binding to this, that and the other, and I thought, well, he must be right. So the next time I went up to the Model Railway Society, I was speaking to some of the men who used to work on the railways in the old days, and I was telling them this story of the scientist at the oil refinery, and they said, yeah, he's right. They said years ago we used to have something called the special stuff in the superintendent's office, and if one of the engine's bearings was running hot, as was common with the inside cylinders of steam locomotives, they used to get some of this special stuff and add it to the oil, and it was rapeseed oil. You live and learn. Thanks for watching, I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.